Have you ever run into a situation where your code behaves unexpectedly? It can be really confusing, right? If you've been scratching your head over the thread create function, you're in the right place. Today, we're diving into a common issue with thread creation in C programming. I totally get it. It's frustrating when you expect your program to print "Hello World" just twice, but it surprises you by printing it more times than you anticipated. You're not alone in this confusion. Many programmers face similar issues. Let's look at the specific question at hand. One user asked, "Why does my program print "Hello World" more than twice when I create 2 threads?" They shared their code and some sample outputs that show unexpected behavior. Sound familiar? Let's explore this together. So, what's going on here? When you create threads, they run concurrently, which means they can execute at the same time. If the main thread finishes before the created threads, it might lead to unexpected results, like printing "Hello World" more than twice. Let's break this down. And stick around. At the end of this video, I'll share a crucial tip on how to manage thread execution to avoid these surprises in the future. To understand why the user is seeing more than 2 prints of "Hello World, we need to consider how threads operate in C. When the user creates threads using pthread_create, these threads run concurrently. In the provided program, the user creates 2 threads. Each thread calls the thread function, which prints "Hello World." However, the main function also continues executing. The unexpected behavior occurs because the main function prints the thread identifiers before the threads have completed their execution. If the main function finishes first, it may terminate the program before the threads complete their prints. To ensure that the user sees exactly 2 prints of "Hello World, they can use pthread_join. This function waits for the specified thread to finish before continuing. By implementing pthread_join, the user can control the execution flow, ensuring that the main function waits for both threads to complete before exiting. This will result in the expected output. Fun fact, the concept of threading in programming is similar to juggling. If you don't keep an eye on all the balls, some might just drop. Managing threads is all about keeping everything in sync. Now, let's look at the answers provided by other users. The user explains that the unexpected behavior you observed is likely due to a thread safety issue. They ran the code multiple times and found varying outputs, including instances where "Hello World" was printed 3 times. This can happen because the main function may terminate before the threads finish executing, leading to incomplete outputs or multiple prints. To address this, they suggest joining the threads in the main function. This will ensure that the main function waits for the threads to complete before exiting, which can help prevent premature termination and unexpected output. However, they caution that this solution does not resolve all concurrency issues, especially if multiple threads access shared resources simultaneously. Let's move forward and look at another answer. This user explains that the unexpected behavior of printing "Hello World" more than twice can occur due to the non-thread safe nature of the printf function. They describe a scenario where 2 threads may interleave their calls to printf, leading to multiple outputs. The user notes that achieving 3 prints is rare, as it requires precise timing between the threads during the buffer flush and write calls. That's the end of that answer. Let's see another perspective. This user explains that when the main program finishes, the subthreads may also terminate. If the main program completes before the threads print their output, you might see fewer than 2 "Hello World" messages. However, if you run the program multiple times in quick succession, the outputs can mix, leading to confusion. For example, you might see outputs from different runs appearing together, which can make it seem like there are more "Hello World" prints than expected. Here's the tip I promised. Always use pthread_join after creating threads to ensure they complete before your main program exits. This simple step can save you from unexpected behavior. And there you have it. By ensuring your main thread waits for the others, you can control the output of your program. If you found this video helpful, please subscribe for more programming tips and remember to keep experimenting with your code.